Let's take a look at 3 varying levels of difficulty of trig proofs using Pythagorean identities and the recip trig functions. This one was so long that I just abbreviated S to be sine, T to be tan, C cos, CT cot in it. Alright, let's look at the easy version. Part A. Prove cot x cosec over 1 plus cot squared is the same as cos x. Now, a lot of students, the first thing they do is they just convert to sine and cos. Now, generally speaking, that's a good strategy to have. However, we need to be well conditioned to recognize the denominator. 1 plus cot squared is cosec squared. Now, you don't need to prove that as part of the proof, but let me remind you how we do prove that. So we have sine squared x plus cos squared x is uno. Then to turn everything into cot and cosec, they both have sine in the denominator, don't they? So we divide through by sine squared. They can ask you to prove this in the exam. So this gives me 1 cot squared is cosec squared. Remember, that's not part of the proof. I'm just reminding you guys how to prove it. So this we can rewrite as cot x cosec x all over cosec squared x, which is nice because now the cosec x is going to cancel that, cancels the squared. And we're left with cot x over cosec x. Now you can write this as cot divided by cosec. We're going to convert everything into cos and sine. You can do your KFC, or you can write here cot as being cos x over sine x, all divided by cosec, which is 1 over sine x. And then you can do some scaling. So on the numerator, if we just multiply that by sine x and the denominator multiply that by sine x, that cancels out the sine x on both the top and the bottom. We're left with cos over 1, which is cos x. And that is a super easy version of one of our proofs. Let's take a look at part B, which is slightly more tricky because we have 2 fractions. Okay? Now, before we do any kind of trig identities or anything like that, we're going to want to bring everything together. So we don't want separate fractions. So for part B, we have sec x over 1 plus sec x minus sec x over 1 minus sec x. This is just a standard bring the fractions together by cross multiplying and bring the denominators together. All right, so we get over. Now with the denominators, you should really notice that that's difference of 2 squares, but I'm not going to skip this step just because I'm doing a demonstration, but I would just do the difference of 2 squares, but I'm going to write them being multiplied. So 1 plus sec x, 1 minus sec x. So I would have already expanded this. So I have this times this. Now, if you guys notice this, if you want, you could factorize out the sec x first. Okay, so if you factorize out the sec x, you wouldn't actually have to deal with it. All right? So it's up to you if you want to do that. Otherwise, you're going to do sec times all of this, and then sec times all of this, and expand. That's what most students would do. So I'm just going to do that anyway. So we have sec x. It doesn't actually shorten the problem by factorizing out the sec x. So you have this times this minus sec x times 1 plus sec x. Expanding, so we have sec x minus sec squared minus sec x minus sec squared all over here. Because it's difference of 2 squares, we just have 1 minus sec squared. Here the sec x cancel. Minus sec squared is minus 2 sec squared. All divided by. Now I notice 1 and sec squared. I know that 1 plus tan squared is sec squared. I'll write it here. And I'll write it here. And I'll write it here. 1 plus tan squared is sec squared. So if I want 1 minus sec squared, I'm basically switching these around. 1 take away sec squared will be minus tan squared. Then the negatives cancel. And the next thing I'm going to do is I'm going to do something very similar to what we did in the previous example. I'm not going to write it separately as a division and do K of C. I'm going to write this as 2. So sec is the reciprocal of cosine. So 2 over cos squared, all divided by tan, which is sine squared over cos squared. These are really good technique, guys, that you should use in your exams. I call it scaling. So here the cos squareds cancel because you're just timesing top and bottom by cos squared. So you can just cross them out. We're left with 2 over sine squared, which is 2 cosec squared x, which is what they wanted. Now, let's do the difficult one. See how it goes. See how the manipulation goes. And then we hope for the best. Okay, so what have we got? We have got sine squared x tan x plus cos squared cot, just cot x, plus 2 sine cos. All right, no, I think that's fine in terms of visually. Yeah, it looks good. All right, so I don't notice any kind of identities here. When we do double angle IDs, you might notice that as a double angle ID, but it doesn't help us because clearly we want to keep everything in terms of the same angle. So that's not helpful. I think then that the best thing to do is to probably just convert everything to cos and sine and just hope for the best. So here I'm going to get sine squared x, tan is sine over cos, plus here I get cos squared x, cot is cos over sine, and then here we just get 2 sine cos. Now it's over 1, isn't it? Because my thoughts are we should probably factorize. Yeah, I think that's the best thing to... Oh, sorry, not factorize. Bring everything into one fraction. Okay, so what are we getting here? My big denominator is going to have cos and sine in it. This is just missing sine, okay? So I'm going to have to times top and bottom by sine. Yeah, so I get cos x sine x in the denominator. So if I multiply that by sine, it's going to become sine squared. Yeah, but timesing by that, it's going to give me sine to the power 4. This one is missing cos. So I'm going to times top and bottom by cos. When you multiply that by cos, it becomes cos squared. Multiply that, cos to the power 4. Plus. Now this, I literally have to times top and bottom by sine cos. This is going to become 2 sine squared x cos squared x. Okay. Now, what are we doing with that? It's a bit of a tricky one. I mean, it's giving me factorizing vibes because, you know, it looks something similar to what we do at GCSE, which is if I give you something like x squared plus y squared plus 2xy. The fact that this coefficient's 1, 1 and 2 is giving me vibes of expanding squared brackets, okay? So if I was to write it with the 2xy in the middle, this factorizes to x plus y, okay? So the root of this is this, and the root of this is this. The root of this is this, and the root of this is this. So this factorizes really nicely to, so imagine this is in the middle, yeah, but we're not dealing with just x anymore. Yeah, we're dealing with the sine squared and the sine to the power 4. So this is something that comes with experience, which is why I'm showing you guys in this video, so that you have more tools in your toolbox, okay? So this becomes sine squared x plus cos squared x, and then another sine squared x plus cos squared x. And if we expand that, sine to the power 4, cos to the power 4, then sine squared times cos squared gives me the 2. And this question here, you could argue is, well, now it's like year 12, isn't it? Because that gives us 1. And then we're left with sine squared plus cos squared over cos x sine x. And how are we going to address that? How are we going to turn it into tan plus cot? Well, at the moment, we have everything being one fraction. We should probably start splitting it. So it's going to become sine squared over, so we get sine squared x over cos x sine x plus cos squared over cos x sine x. Here, the sines cancel. We're left with sine over cos, which is tan x, plus the cos x's cancel, and we're left with cos over sine, which is cot x. And that has been proved. So that's still quite a tricky example because of this. Yeah, being able to recognize that would be regarded as quite tricky. But now that you guys have seen this, you're not going to make any mistakes of this in this for sure. But guys, if you learned something today, I'd appreciate if you hit the like button, subscribe for more maths content. If you're interested in my A-level maths courses, links are in the description. And feel free to join my Lung Gang Reddit page if you want to submit your own questions. I'll see you guys in the next video. Nice.